This meeting is being recorded.
Okay, where were we in last class?
We were talking about momentum.
Okay, momentum. I think in momentum we have discussed the impulse equation. What is the last equation you have written?
Mass times velocity.
Mass time velocity. Okay, I think you have written Ft equals to mv minus mvu, which is an impulse equation. Correct? So up to there we have studied. Now have we done the numerical as well for this?
You didn't give me a numerical last lesson.
Okay. So see, basically, what was the momentum? Can you just introduce me with momentum? What is momentum? How can you define momentum? Or you can explain me with an example also?
Okay, first of all, it's a force,
Hmm.
and it depends on an object's motion and its acceleration.
Not acceleration. It depends on, it's like a product of mass with velocity. It will give you momentum. That means how big the force is, what is the mass of it, and how much velocity it is taking. That is the momentum. Now, how it is related with impulse? What is impulse, if you remember?
It's impulse is also a type of force. It's the
It's like a force
when momentum
multiplied
is
with
done
time.
quickly.
Yes.
When momentum is done quickly, it's called an impulse.
Yeah, we can say that. It's not like when momentum is done quickly, it's like when a big amount of force is applied in a shorter duration of time. Force is big, time is less. Okay, then that Ft equals to your impulse. Now this impulse is also equals to momentum. Mv minus mv, change in momentum. Not momentum, it's the impulse is equals to change in momentum. So sometimes when a small numerical can come for 1 mark, like impulse is given to you and change in momentum you have to find, or sometimes V or U is given, you have to find out the impulse. So it's like a formula based thing. Okay, you have to use formula impulse equals to what? Impulse equals to change in momentum. So this is the formula. Now what is the formula for momentum?
Mass times velocity.
Correct. Momentum, I can write it like mv. How does it denoted?
P, small p.
Correct. Small p. It is mv. Impulse equals to another formula for impulse.
F times t.
Correct. Now this four formula we have, and then by using this we have to find the answer for the given numerical. Okay. Write down the first numerical. A car of mass. Car of mass 600 kg.
Just a
600.
second.
Okay.
Can you repeat that?
Yeah, a car of mass 600 kg is moving at 15 meter per second, 15 meter per second. Calculate its momentum. Calculate its momentum. This is part A. Then part B, the driver accelerates gently. The driver accelerates gently so that a force of so that a force of a force of 30 Newton 30 Newton 30 Newton act on the car act on the car act on the car for 10 seconds for 10 seconds for 10 seconds. Calculate the impulse of the force. Calculate the impulse of the force. Part C. Calculate the momentum. C part. Calculate the momentum. Calculate the momentum of the car after after the accelerating force after the accelerating force has acted on it. After the accelerating force has acted on it. Now try to find out the answer. Formula is in your screen.
I'm not really sure how to do the second and third part. Can we do it together?
Okay. So what's the answer you're getting for the first part?
9,000.
9,000
9,000.
or 100?
1,000.
600. Okay, 9,000. Unit?
Um, for momentum, it's.
From the formula you can find out. From the formula you can easily find out the unit. I told you how to find the
Oh,
formula.
it would be kilograms meter per second.
Correct. Now second is, what is given to you? Force is given to you. How much force is given? 30 Newton. Time is given to you, 10 seconds. And now they are asking for impulse. What is the formula of impulse? Acting?
It's
Right.
force times. It's 300
Correct. It's an easy one. What will be the unit?
newtons
Newton and
per second.
per second or second. Newton second. It's multiplied, na?
Oh,
Into T.
mhm.
So it's Newton second. Now, third one is they are asking for momentum of the car after the accelerating force has acted on it. That means there is a condition. Now, what is the condition? What the situation is created in this numerical? There was a car. Suppose this is the car. Car has the mass 600 kg, moving with velocity 15 meter per second. Okay, this is the initial condition. This is the car. This is moving with 15 meter per second velocity. Now, suddenly in part B, what is written that driver gently apply a force. How much force the driver is applied in forward direction? It applied 30 Newton force for 10 seconds. Okay, when the driver is applying force, that means what happened to the car? Car will accelerate. The driver is applying the force. Force where? It is giving the accelerator. Driver wants to move the uh, driver wants to increase the speed of car. So driver apply the force of 30 Newton. Now once the 30 Newton force is applied, what happened to the car? Car will start moving with greater velocity, isn't it? It got
Mhm.
accelerated. So after applying of force, there will be acceleration in this car. This is the whole situation which I understand from reading the question. Now, in the numerical, we are asked what will be the final momentum. Okay, read the question again. Read the C part. It is, they are asking, they are asking what is the final momentum. It is the momentum of the car after the accelerating forces of acted. That means initial momentum, whatever the momentum you have find in part A, that was your initial momentum in the given
Mhm.
initial conditions. Okay, so you are getting 9,000. Fine. Then
Mhm.
after getting this, what you have to do? This was the initial. After that, force is applied. After application of the force, the momentum got changed. Momentum got increased or decreased. That depends on your force. The force is positive 30 Newton. That means in the positive direction, in the forward direction only. Your final momentum will be increased definitely as compared to the initial momentum. So how can you find? You have impulse and you have one formula that impulse equals to change in momentum. Change in momentum means what? If I write like this, impulse equals change in momentum. Change in momentum is final momentum minus initial momentum. This is what change in momentum means, no? Final minus initial.
Mhm.
And you are supposed to find out final moment. So if you add initial momentum is impulse, you will get the answer. Impulse you have already calculated in part B. Initial momentum you have calculated in part A.
But isn't impulse only for the acceleration? Ah, okay, I got it because it's minus. Okay, so it would be 300 newtons second would equal to But they're different units. Would that not matter?
Sorry?
Just a second. So would it be 700?
How can it be 700? You have, okay, you have 9,000 minus 300. What will be the
Or
sorry?
yeah.
What answer you are getting?
Sorry.
What you are saying? 9,000 minus 700, 300, sorry. 8,700 is the answer. What the answer? What will be the unit then?
Also kilograms meter per second.
Now, sometimes some student got confused. In the last class only when I was teaching the same thing, one student asked me, ma'am, how can we add impulse with the momentum? Because impulse is Newton second and your momentum is kg meter per second. What do you think? How we are adding? Understand the question? Understand the doubt?
No, not really.
Okay.
Can you repeat it?
Here what we are doing impulse plus initial momentum for finding out what? For finding our final momentum. Now the question asked from that student was, this impulse have the unit of Newton second and this initial momentum has the unit of kg meter per second. Now you told me that always whenever you have to doing addition or subtraction, the unit should be same. This is the basic rule, isn't it? Now the units are changed, still you are adding them. How is it possible?
I'm not sure.
In the last class I have explained, I think you have forgot. This Newton second and this kg meter per second both are same. How? What is Newton? Newton is for force. Force is
Yeah.
equals to me from the Newton second law.
Mm-hmm.
M is kg. Acceleration is meter per second square. And if I'm writing NS, it means Newton multiplied by second. That means this kg meter per second square multiplied by second, you will get kg meter per second. Understand?
Mm-hmm.
Is it clear or not?
Wait, so they're both forces, but then when I add them,
Mm-hmm.
what would be the new unit?
See, it's the basic rule that whenever we are adding or subtracting, it's not about the only the magnitude. It's not about that you are adding 300 with 900. It's not about the magnitude. You have to check about the unit as well. When the unit is same, then only you can add or subtract. Okay, for addition and subtraction, unit should be same always. This is not necessary for that multiplication and division. Multiplication and division can be done with any units. But for adding and subtracting, the unit should be same. Now here, the doubt of that student was very nice that he was asking that Newton second is 1 unit for impulse. Now you are adding initial momentum to get the final momentum. Both the units are different. How can you add? Okay, this type of question is asked of some extraordinary thinking child. He's not just really wants to study normally. He wants to think something different beyond the boundaries. His doubt was nice, but We forgot that I told you that Newton second and kg meter per second, they both are same. How both are same? Because Newton is MA, Newton is the unit of force and force equals to MA from Newton second law. That means kg meter per second square. And if I write Newton second, that means I have to multiply second. So this denominator second square got cancelled out with this second. What is remaining? Kg meter per second. That means Newton second and kg meter per second both are same. So we can add it. Although the representation is different, but still both are same. So we can add it. Clear?
Okay, clear.
Now write down next numerical. First question. Calculate the momentum. Calculate the momentum of a car of mass 600 kg of mass 600 kg moving at 25 meter per second. Moving at 25 meter per second. Next question.
25.
Sorry,
25 meters per second.
that's it. This is the first question. Question number 1. The next question, question number 2.
Okay.
A force of 20 Newton. A force of 20 Newton acts on a rocket. Acts on a rocket. Acts on a rocket for 350 seconds. For 350 seconds. For 350 seconds, causing rocket's velocity, causing rocket's velocity, causing rocket's velocity to increase, to increase. Rocket velocity to increase. Number 1, calculate the impulse of the force. Calculate the impulse of the force. Number 2, by how much force, by how much force the rocket speed, by how much does the rocket momentum increase? By how much does the rocket momentum increase? By how much does the rocket momentum increase? Try to solve. Again, the same formula will be used.
Okay, for the first one, I got 1,500 kilograms meter per second. For the second one, I got 7,000 newtons second. And for the last one, oh wait, I wrote something wrong. I'll just correct it and I'll give you the answer.
Can you please repeat the answer for the first one?
It's 1,500 kilograms meter per second.
Correct. Then both are correct. Correct. Now you got it. It will be very simple type of question. The only thing you have to understand the relation between the impulse and the how the impulse and this change in momentum is related. Okay, and that to change in momentum equals to final momentum minus initial momentum. Because sometimes they'll ask for final, sometimes they ask for initial. So don't get confused. From that change in momentum means what? Final minus initial only. So from that formula we can get the answer. Clear?
Mhm.
Now next
Okay.
step is momentum in a collision. Momentum in a collision. Now see, collision means what? Suppose you are playing a cricket match. You are playing a cricket match. That means there will be one bowler, one batsman. Bowler will throw the ball, and batsman will hit that ball. So where will be the collision? When the ball reaches the bat, there will be a collision. Collision between what? Collision between the ball and the bat. Now, how the momentum got changed whenever there is a collision? Suppose you are throwing one. Suppose you are throwing one tennis ball or one football towards the wall. What happened? It will come bounce. It will bounce back and come back to you, although with the less velocity or whatever, depending on upon its mass. So what happened to the momentum whenever there is a collision that we have to understand from this topic. Okay. Whenever whenever you are playing a badminton, what happened in badminton? Where the collision happen? Collision between
On
which
the
happen?
net.
Correct. Between the racket and your cock, isn't it?
Mm-hmm.
So this type of collision. So in the exam, you can get. I don't think very typical numerical will be given to you. Numerical. See, in your course, in your syllabus, the numerical will be easy. Numerical will be mostly formula based. The theory
Mm-hmm.
portion will be much more concept based. Okay, but they will twist the thing. They will twist the question in terms of understanding whether you have understand the topic or not. They don't want to think whether you are good in calculation or not because calculator you can use easily. They focus more on the your concept, how you are applying the concept. If you are writing a numerical, so that numerical, how much deeper knowledge you have for that numerical. Sorry, what that formula. If you are writing impulse equals to change in momentum. So what do you mean by that impulse term? What is that impulse? How can you relate that impulse with the momentum? This the examiner wants to judge. Yeah.
Okay.
Whenever you are writing a single word, that word has its own meaning. We have to go through it. Okay? Your syllabus is so vast, but still you have to go through each and every formula, each and every equation, each and every. They will never ask for the definition. They will never ask what is the definition. Write down to the definition of momentum. No, they'll ask something concept depend on that momentum. Like what happens when a bowler throws a ball towards a batsman. Now you have to explain the collision momentum. What happened in the momentum when there is a collision between bat and ball. You have to write down the concept. They'll give you some situation and they'll ask which principle is applied here. Four options will be given to you. Impulse, momentum, change in momentum, law of conservation of momentum. The answer will be law of conservation of momentum. That is our new topic that we are going to deal now. So understand how the question will be framed. Whenever they are asking, they'll give you a situation, they'll give you a figure. Now from that figure you have to analyze which from how I can relate any concept from that given figure. So you have to analyze. Suppose some question is new to you, don't think that it is new. It will be there from your syllabus only, and we have covered every topic from your syllabus. So go through that question twice or thrice, you will get the answer definitely. Okay. Sometimes it happens that it got click in your mind at that very moment. Later, when you submitted your answer sheet, it clicked that, oh, I can write that. So this thing happens, but for that, what you can do, you can read the question twice or thrice. Definitely, they will be there in your mind. You understand how to relate it. Yeah. And from where you can get this knowledge, when you read the whole notes copy clearly, when you read it, when you go through it. Okay? And if you just pick up some important topic and just mug it up, read it up, analyze it, and go in exam, you will never get good marks. You have to follow the sequence in which I am teaching. Now write down momentum in a collision. Written. Now write down figure shows a game in which ball hangs from a length of string. Length of string. First off, the player hits the ball. The player hits the ball horizontally with a racket.
Wait, can you repeat after string?
Full stop. The player hits the ball. The player hits the ball. The player hits the ball horizontally with a racket. Horizontally with a racket. Next paragraph or next bullet. We can use the idea of momentum. We can use the idea of momentum to describe the situation. Full stop. Next, point number one. Point number one. Before the collision,
Can you just repeat the last one? We can use the idea of momentum to explain the what?
to describe what happens.
Mhm.
Number one, before the collision. Before the collision. Underline it. Write down. The racket is moving to the right. The racket is moving to the right. It has momentum. The racket is moving to the right. It has momentum. First off, the ball is stationary. Rocket, well, the racket is moving to the right. Racket is moving to the right. It has momentum. Full stop. The ball is stationary. The ball is stationary. So it has no momentum. So it has no momentum. Next point. Point number two. After the collision. After the collision. Write down the racket is moving to the right. Racket is moving to the right. Racket is moving to the right. But more slowly than before. But more slowly than before. It has lost momentum. It has lost momentum. First, the ball moving rapidly, ball moving rapidly the ball moving rapidly to the right, it has gained momentum. It has gained momentum. Then change the point. 2 points are completed. Then make another bullet and write from above observation. Observation. From above observation, we can see that. We can see that. We can see that when the racket when the racket exerts a force exerts a force on the ball, momentum is transferred momentum is transferred from the racket from the racket to the ball. Momentum is transferred from the racket to the ball. Change the bullet. Whenever a force exerts, whenever a force acts on an object, whenever a force acts on an object,